sharing screen. So my screen is visible, right?
Yes.
Okay. So we'll take the problem sheet 4 and we'll discuss mostly questions on residue and everything. So let me start by question number 9. So I hope you all know about calculation of residues and you all know about the Cauchy residue formula. So anyways, I'll discuss few things. So should I discuss something regarding residues or should I start with the question directly?
Questions.
Okay, then fine. So if let me write down the question. So let gamma r t, this is a circle with radius r for t in 0 to 2 pi. Okay, and r is the radius of the circle which is greater than 0. Now calculate the following integrals using the Cauchy residue theorem. The first integration is integration over gamma 1 cot z dz. So basically what does the Cauchy residue theorem says? This is nothing but 2 pi I. I'll write it very informally. So 2 pi I, and here you have to write, or basically sum of all the residues. I'll just write it informally. Want to suppose k and residue of the function, if this function is f, so f at the point zi. So I'm not considering the winding number because every circle has winding number 1 in this interval. So what is my point? That just a minute. So if I consider this as the function. So to apply the Cauchy residue theorem, you have to first find out what are the singularities of this function inside the circle gamma 1. So what does gamma 1 represents? So gamma 1 is r is 1 here, so it is just e to the power of it. That means it is a unit circle. So inside the unit circle, what are the singularities of this function fz? So notice that fz is nothing but cot z, which is what? Cos z divided by sin z. What are the singularities of this function? How will you calculate the singularities of this function?
Zeros of sine.
Correct. So the singularities of this function is all those z where sin z is 0. And where is sin z 0? At z equals to
n pi.
N pi.
Right. Singularities of fz are z equals to n pi, where n is any integer. Right. Now, but you have to take only those singularities into consideration which is inside this gamma 1. So gamma 1 is a unit circle. Among these z, can you tell me which are the points which will lie inside gamma 1?
Z equals to 0.
Z equals to
0.
0. Only z equals to 0 will lie inside gamma 1 because gamma 1 here represents the radius of the circle, right? So the circle is like this, the radius is 1, and only z equals to 0 will lie here because the next point is pi or minus pi, so which is much more larger than 1, so that will be outside the unit circle gamma 1. So what is the point? Only, so but z equals to 0 is the only singularity of f lying inside gamma 1. So we are done. We have to just, so what does the Cauchy residue theorem says? We have a point where which lies inside, which we have a singular point which lies inside gamma 1. At that point you have to find the residue of the function. So we are supposed to find the residue of the function at z equals to 0. So can you tell me how to calculate this residue? Okay, so whenever sir has done this theorem, whenever a function is of this form and z0 is a simple zero of bz. Okay, so what is the meaning of simple zero of bz? That means b of z0 is 0 and b prime of z0 is not 0. So what does this mean? This is equivalent to say that b of z0 is 0 but b prime of z0 is not 0. Then what is the residue of the function at the point z0? It is a z0 divided by b prime z0. So z0 is a simple zero of bz, which is same as saying z0 is a pole of f, of simple pole, basically simple pole of. Okay, so whenever you have a function of this form az over bz and where z0 is a simple zero of bz, simple means this condition, then residue can be easily calculated like this. Keep that in mind. So now can you tell me how will I calculate the residue in this case? It will be, it is of the form cos z by sin z. So consider bz as sin z and b of 0, that is sin 0 is 0, but derivative of sin z evaluated as 0 is not 0. So residue will be cos 0 divided by, right, you said 1, that is correct. I'll just do the evaluation. Derivative of sin z, or I should not write the derivative this way, I'll write this way, derivative of sin z and evaluated at the point z equals to 0. What is this? Cos 0 is 1, derivative of sin z is cos z, and at 0 is cos 0 is again 1. So the residue is 1. Am I clear with the calculation of residue? Keep this theorem in mind because this will be very much helpful in evaluating the residue whenever you have this condition. Okay, so if the residue is this, we are done. So therefore integration over gamma 1 of cot z, this is nothing but 2 pi I times the sum of all the residues. So there is only one singularity, so just, and what is the value of the residue? That is 1, and winding number is also 1 because this is a complete circle and it is, the interval is from 0 to 2 pi, so winding number is also 1, so it is 2 pi I. So this is the answer to the first problem. Am I clear? Do you have any problem? Okay, just a minute. So let's go to the second problem, number B. So gamma 2. So what does gamma 2 represent here according to the definition? Circle of radius 2 and centered at origin. 1 by z minus 4 and z cube minus 1 dz. Okay, So if I consider this function, let fz is equals to 1 by z minus 4 z cube minus 1. So can you tell me what are the singularities of this function?
T1.
4, 1 omega omega square.
Right, that's correct. So you know, that's very simple thing. You have to, if I'm asking you the singularities of this function, you equate the derivative, you equate the denominator to 0. So the singularities of f are given by, so z minus 4 equals to 0 and z cube minus 1 is equals to 0. So z minus 4 is 0 implies z is 4 and z cube equals to 1 will implies that z is either 1 omega omega square, right? Where what is omega? Where omega is e to the power 2 pi I by 3 if I am not mistaken. So it is the a complex cube root of unity, right? Okay, that's fine. So what is the curve given to us? Gamma 2. Gamma 2 means the radius is 2, 1 and 2. So this is 2. So you have this unit circle, not unit circle, this curve gamma 2. Okay, because the radius here is 2. How do I know that the radius is 2? Just look at the definition of gamma RT. Here 2 will come, so this is gamma 2. So can you tell me, among these 4 singularities, 1 omega omega square and 4, which are inside this gamma 2? Okay, you want to tell me?
1 omega omega square.
That's correct. 4 is not there definitely. Okay, so because 1 omega and omega square will lie on this circle, unit circle. So 1 is here, omega will be somewhere here, omega square will be somewhere here. Okay, so they all are inside this unit circle gamma 2, but 4 is outside. So what is the therefore by the Cauchy residue theorem, what I know that this integral over gamma 2 1 over z minus 4 and z cube minus 1 dz, this is 2 pi I. Again note that the winding number is 1, so we will not take winding number into consideration, and residue of the function at 1 plus, you have to sum all the residues, plus residue of the function at omega and plus, it is this, maybe this is not required, plus residue of the function at omega square. So this is what the Cauchy residue theorem says, that the value of this integral will be 2 pi I times the sum of all the residues. So you can just write one more line here. Among these 4 singularities, only 1 omega omega square lies inside gamma 2. So we will be done with this question if you can find these 3 residues. So what is the residue of the function at the point 1? Can you tell me? Again, notice that fz is of the form az by bz, and z equals to 1 is a simple 0 of this one, z cube minus 1. So you can better write this function in this manner. 1 by, this will be helpful in calculating the residue, z minus 4 and divided by z cube minus 1. And think this as the form az by bz. Right? So now can you tell me, you see that 1 is a simple 0 of z cube minus 1. Why? Because if bz is z cube minus 1. What is the derivative of bz? It is 3z square. B of 1 is 0, but b prime at 1 is not 0. Okay, so tell me, right? So let me write it down. I hope you will understand this. 1 by 1 minus 4 divided by 3 into 1 square. You agree or no?
Yes, sir.
Right? Because I'll just simply repeat. You have to write. Okay. Let me. If some of you have not understood this, just apply the formula. This is a at 1 divided by b prime at 1. As simple as that. So a of 1 is what? 1 by 1 minus 4, and b of b prime is what? 3z square, and z is 1 here. This is nothing but minus 1 by 9. Okay, similarly, residue of the function at omega, which will be again in the same manner, because b of omega is again 0 and b prime of omega is again not 0. So again omega is a simple 0 of bz, and as a result it is nothing but a of omega divided by b prime at omega, and this is by the same calculation it will be 1 by omega minus 4 divided by 3 omega square, which is nothing but 1 by 3 omega square omega minus 4. And similarly the residue of the function at omega square will be, if you compute, 1 by 3 omega to the power 4 by omega square minus 4. I hope you will understand this, not a problem. So omega to the power 4 is same as
Omega.
because omega cube is 1. So this is my thing. So we are done. If you find this sum of these three. Okay, so let's find out the sum of these three. So therefore residue of f at 1 plus residue at f of omega and residue at f at omega square should be semicolon. So let's find out the sum. This is equal to minus 1 by 9 plus 1 by 3 omega square omega minus 4 plus 1 by 3 omega square minus 4. So here you have to calculate a bit. Okay, anyways, I'll show you the calculation, otherwise some of you may make some mistake. So this is, you can take 1 by 3 common, so I'll remain with minus 1 by 3 plus 1 by omega square omega minus 4 and plus 1 by omega square minus 4. So let's take the LCM, keeping 1 by 3 as it is. So what is the LCM? 3 omega square omega minus 4 omega square minus 4. I'll remain here with minus omega square omega minus 4 omega square minus 4. This is the first term. What will be remaining in the second term? Can you tell me? 3. So omega square is already there, omega minus 4 is already there, so omega square minus 4. And for the last term, 3, 1 omega will be there, omega square minus 4 is there, so omega minus 4 will be there. Please verify, okay? So start calculating this. This you have to calculate a bit. Okay. So you keep this as it is, minus omega square. You please multiply this two. So I'll remain with, if I multiply this, omega into omega square is omega cube, which is 1. Then minus 4 omega square minus 4 omega and then plus 4 4 is 16. I'm getting this. This is 3 omega square minus 12 and this is 3 omega square minus 12 omega and divided by 3 omega square. Again you multiply this 2, so this will be omega cube, which is 1 minus 4 omega minus 4 omega square plus 16. Okay, now you see what I'll do. Minus omega square. Remember 1 plus omega square is 0. So from here what I have, omega plus omega square is minus 1. So look at these two quantities. If I take minus 4 common from this 2, if I take minus 4 common from this 2, I'll get minus 4 into omega plus omega square. Omega plus omega square is minus 1. So minus 4 into minus 1 is 4. So 16 plus 4, 20. 20 plus 1 is 21. So this is minus 21 omega square. I'll write it directly. Minus 21 omega square. Right? Again notice this. 3 omega square is 6 omega square. And again you see this. Look at this one. So minus 12 omega. If I take minus 12 common, I'll remain with 1 plus omega. And again from here, what is 1 plus omega? It is minus omega square. So this is minus 12 omega square. No, so plus 12, right? Because 1 plus omega is minus omega square. So I'll remain here with plus 12 omega square. So just keep these things in mind. And similarly, in the denominator, because this thing and this thing are same, so this will also be 21. So this is again nothing but 3 omega square into 21. And we are almost done because this is nothing but 1 by 3. If we compute the numerator, this is what? Minus 3 omega square. And here I have 3 omega square into 21. So these two are getting cancelled. I'm getting minus 1 by 63. So what is the answer? So therefore, integration over gamma to 1 by z minus 4 into z cube minus 1 dz. This is nothing but 2 pi I times the sum of all the residues, which is minus 1 by 63. So the final answer is minus 2 pi I divided by 63. Any confusion? Okay. Now, before going to the third question, I want to discuss a question with you all. So I am giving you a question. So this is gamma 2. So gamma 2 is, you know that, according to the question, dz by z cube times z plus 4. Okay. So can you tell me what are the singularities of this function?
0 minus 4.
That's correct, 0 and minus 4. And among these singularities, which is the one which will lie inside gamma 2, or which are the ones which will lie inside gamma 2?
Only
Only
0.
That's correct. So z, if I let this as fz, so let fz is equals to 1 by z cube times z plus 4, then z equals to 0 is the only singularity of f lying inside gamma 2. Okay, but note that, so we are done. That 2 pi I times, so what is the value of this integral? This will be nothing but 2 pi I times the residue of the function at 0. We are done. If we can calculate this, we are done. We don't have to compute anything else. But note that you cannot apply this formula to compute the residue this time. because z equals to 0 is not a simple 0 of this one, is not a simple 0 of this one, right? So how will you compute the residue here? So we know that z equals to 0 is a pole of order 3 of fz, or of f basically. Z equals to 0 is a pole of order 3 just due to the fact that this cube is here, right? So Z is a 0 of pole of order 3. This, but in the previous questions, whichever question I took, like this one and the first one, there the poles was basically simple pole. But the question which I have taken here into consideration, this has a pole of order 3. So can you tell me how to calculate the residue therefore? So how will I calculate the residue therefore?
Z प्लस 4 को मान लेंगे सर, 2 बार डेरिवेटिव कर देंगे.
कितना बार डेरिवेटिव करोगे? See, again this theorem has been discussed.
सर ने बताया था उसको.
हाँ. So when
जैसे m ऑर्डर का पोल लो तो m,
right. So if f has a pole of order k or n, doesn't matter, then pole of order k, pole alpha suppose of order k, then residue of the function f at alpha, this is nothing but 1 by k minus 1 factorial times d2 dz2, oh sorry, k minus 1, you have to differentiate k minus 1 times I have given a bracket here of the function z minus alpha whole to the power k times fz. So this is the rule basically. This is the formula which sir has derived in the class. So using this formula, can you tell me what should I write here in this case?
1 by 2 factorial
1 by 2 factorial
d2 by dz2,
right, the second derivative of
1 by z plus 4.
right, because if I write here z minus 0 whole cube and times fz is 1 by z cube times z plus 4, and this 2 will get cancelled, so I'll simply remain with 1 by 2, and I have to differentiate this 2 times. I have to differentiate this 2 times and evaluated, sorry, this should be evaluated at z equals to alpha. So this should be evaluated at z equals to 0, and this differentiation should be evaluated at z equals to 0. So this is half. So what is the differentiation of this 2 times? So first derivative is minus 1 by z plus 4, and the second is minus 2 by z plus 4 whole cube. So minus and minus will become plus. So 2 by z plus 4 whole cube, and this will be evaluated at z equals to 0. What will I eventually get? So this 2 and 2 is getting cancelled. I'll remain with 1 by 64. Therefore, the required integral, the required value of the integral is 2 pi I times the residue, which is this, and this is nothing but I pi by 32. So this is an extra question which I thought of discussing, because here the calculation of residue will be a bit different due to the third order pole present in the function. Okay, so keep these things in mind. It's not like you have to always evaluate in the same manner, so use the theorems properly. And yeah, so if I have taken a circle of radius suppose 5, then this will also, the z equals to minus 4 will also be a pole of this function, and to find the residue of the function at minus 4, you can use this formula. Okay, so any confusion with this question?
सर यदि फिफ्थ रूट ऑफ यूनिटी आ रहा हो उस केस में क्या करना?
वो रेयरली चांस है कि आएगा, बट अगेन अगर आ रहा है तो तुम लोग को इस हिसाब से रेसिपी कैलकुलेट करना पड़ेगा समवॉट. देयर इज नो अदर ऑप्शन, बट that chance will be very less. Okay, so next.
हेलो सर.
हेलो.
हाँ सर, यदि फिफ्थ रूट ऑफ यूनिटी हुआ तो उस केस में कैसे करेंगे सर?
अच्छा देखो, कैलकुलेशन जो मैंने थर्ड रूट ऑफ यूनिटी में किया वैसे ही करना पड़ेगा, बट मे बी वहाँ पे कैलकुलेशन थोड़ा ज़्यादा रहेगा और कोई ऑप्शन नहीं रहेगा हमारे पास, बट चांसेस बहुत कम है कि फिफ्थ रूट ऑफ यूनिटी को देगा. ओके
सर वो इन्फिनिटी पे रेसिड्यू डिफाइन करके उस तरीके से नहीं कर सकते क्या? मतलब सर ने करवाया नहीं है लेकिन
हाँ एक और तरीका है, दैट इज राइट, कि तुम सारा सिंगुलरिटीज नहीं लेके सिर्फ एक कन्वर्टिंग द सिंगुलरिटीज एट इंफिनिटी, उस हिसाब से भी कर सकते हो, दैट इज फाइन.
कर सकते हैं ना सर, मतलब सर पूछे तो उस तरीके.
हाँ दैट कैन आल्सो बी डन.
ओके.
So next one, number C. Okay, one more thing. हाँ, अगर ये सर्कल लाइक ये सर्कल का इंटरवल कितना दिया था 0 to 2 pi. If I take here 0 to 4 pi, then the winding number will become 2, and यहाँ पे तुमको 2 से एक्स्ट्रा मल्टीप्लाई करना पड़ेगा. So answer will be 4 pi I in that case. So here the circle has just basically the winding number is 1. तो यहाँ पे that I'm not taking into consideration, but keep these things in mind whenever your circle is of this form, t from 0 to 2 and pi, then the winding number of this circle is nothing but not circle, मतलब जो point है उसके बाहर का वो चीज, then it is n. उस केस में you have to consider the winding number into the Cauchy residue theorem. Okay, so next one, number C, again gamma 1 sine 1 by z dz. So can you tell me what is the singularity of this function?
Zero. Essential singularity.
Only 0. So what kind of singularity is 0? Is it a pole or an isolated singularity or an essential singularity?
Essential.
Essential, because it, so why essential? You can just see that. So what is the series of sine z? It is z minus z cube by 3 factorial plus z to the power 5 by 5 factorial and so on. So minus will come here, right? So just replace z by 1 by z in this expansion. So sine z is nothing but 1 by z minus 1 by 3 factorial z cube plus 1 by 5 factorial z to the power 5 and so on. So you can see that because the negative powers of z are infinite in number, so at 0 we have essential singularity. So can you tell me what is the residue of the function?
1, sir.
Right, because what is another definition of residue, or that is the first definition by the way, that residue is the coefficient of 1 by z in the Lorentz series expansion. So 1 by z का जो भी coefficient होगा वो होगा तुम्हारा residue. So what is the residue of the function f at 0? What is the coefficient of 1 by z here? You can clearly see is 1. So the residue is 1. So therefore this integral is 2 pi I, and this 0 lies inside this, so inside gamma 1, so this is 2 pi. This is the answer. So whenever you have an essential singularity, you do not have any formula to calculate the residue, you just write down the Lorentz series expansion, and then from there find out the coefficient of 1 by z. That will be your residue. For poles, we have the formula for residue, and for isolated singularity, the residue is always 0. And for number D, z e to the power 1 by z dz. So again, it is very simple. If you write down the Lorentz series expansion of this, so what is for e to the power z? It is 1 plus z square by 2 factorial. So replace z by 1 by z. So 1 plus 1 by z plus 1 by z square times 2 factorial, 1 by 3 factorial z cube. So this is nothing but multiply by z throughout. So z plus 1 plus 1 by 2z plus 1 by 3 factorial z square and so on. Let me have 2 factorial only. So what is the residue of the function?
1 by 2 factor.
Right. 0 is 1 by 2 factorial, which is 1 by 2. So, and note that 0 lies inside gamma 1. So therefore, you can justify those things. Z e to the power 1 by z. This is 2 pi I times half. The answer is pi I. Right. So do you have a confusion? If you have some confusion, you may ask. So if you remember the Cauchy residue theorem, you don't have to memorize the Cauchy integral formula anymore. You can now see the Cauchy integral formulas can actually be obtained from the Cauchy residue theorem. Okay, so just follow that. That will be very simple. So Cauchy residue theorem, if you can remember the Cauchy residue theorem, you don't have to remember the Cauchy integral formula. It can easily be obtained from the Cauchy residue theorem. Okay, so let me go to number 10. You have to calculate the residue of the function 1 minus e to the power minus z minus n at 0 and prove that this residue will be 1. Okay. So first of all, tell me, if I take this function, let fz equals to 1 minus e to the power minus z whole to the power minus n, which is, this is what, 1 by 1 minus e to the power minus z whole to the power n. So can you tell me what are the singularities of this function?
Z equals to 0.
Sorry, you are not audible.
Z equals to 0.
2n pi iota.
Okay, only one? No. How will you find the singularities? Just equate this to 0. That means e to the power minus z is 1. Or you can also say, from here you can also say e to the power z is 1. And when is e to the power z is 1?
2 pi in.
Right, 2n, I'll write k because n is already used in the question. 2k pi I. These are the singularities. So what are the singularities? There are many singularities at 0, any even multiple of pi I. These all are the singularities. Okay. So that's fine. So but we want to find the residue only at 0. Okay. So let what I'll start with, you see this, let C be any regular closed curve surrounding z equals to 0. I'll tell you why I'm doing this, and not surrounding any of the other singularities z equals to 2 k pi I, and k is plus minus 1 plus minus 2 and so on. So what is my point? I'll tell you why I'm doing this. I'll use, you know, if I use the Cauchy integral formula, what is this integration? This c is same as this c. This c and this c are same. Okay, just notice that. What is this by the Cauchy residue formula? Can you tell me? 2 pi I times residue of the function only at 0. Why only at 0? Because C is only that curve which contains 0 and no other singularity. So inside this curve C, or inside this curve C, only 0 is the singularity of the function fz. So by the Cauchy residue formula, I have this. Do you agree with me what I have written? I hope you are getting my point. So my point is that why I am choosing such a weird curve? Because I want to choose such a curve such that only 0 is there and no 2k pi I multiples lie inside C. So by the Cauchy integral, by the Cauchy residue theorem, this integral is nothing but 2 pi I times residue of the function at 0. Do you agree with me?
Yes, sir.
Right. So we are now back tracing things. We will compute this residue by computing this integral. So what will be the residue from here? The residue will be this. The residue will be this. So instead of computing this residue, we'll compute this integral. So we are going back, we are going in the opposite manner this time. So I'll simply write that. Then by the Cauchy residue theorem, what we have, residue of the function, I'll simply write this function at 0 is 1 by 2 pi I times this function again. So function is this only. I'll write whole to the power n this time. D. So evaluating this residue is same as evaluating this integral. Both are same. So we'll now focus on evaluating this integral. And such a choice of C is definitely possible. Why? Because if I choose C as the unit circle, then only 0 will be there and no other singularity will be there. So such a choice of C is definitely possible. We can do that. Okay. Oh, just a minute. I made a mistake. I have to write here C. Right. Now let's evaluate this integral. Let omega equals to 1 minus e to the power minus z. So substitution basically. I am writing w as 1 minus e to the power minus z. So from here e to the power minus z is 1 minus omega. Start differentiating. So minus e to the power minus z dz is nothing but minus d omega. So dz is nothing but d omega by e to the power minus z. E to the power minus z is nothing but 1 minus omega, right? So therefore, okay, instead of writing this whole integral again, call this integral as I c. Okay, so what is I? Therefore I is nothing but 1 by 2 pi I. Okay, this is 1, so this is 1 by omega to the power n, then 1 minus omega d omega. But this C will not remain same because you have changed the plane this time. So previously you are in the Z plane, now you are in the omega plane. So here the curve will also change. So suppose the curve is C star. What is C star? Where C star is the image, because when you are changing when you are transforming things, you have to also transform the curve. Okay, so where C star is the image of C under the transformation 1 minus e to the power minus z omega plane. This is omega, right? Okay, so again you have to find this integral. Now we can choose C in such a way that C star contains 0 and not 1. So again we are claiming something, that such a choice of C is possible such that the new curve C star contains the point 0 but not 1. So this is possible. I'll not prove. You can see the Joseph Back book, there they have shown such a choice of C as a rectangle. So I'm not doing that anymore. So we can choose such a C, like for instance, if I choose this C, for instance, choosing C to be the boundary of the rectangle -1 lesser equals to x lesser equals to 1, comma minus pi by 2 lesser equals to y lesser equals to pi by 2 works. That means you can prove that if you find out, like that will be basically not an easy job to find the image of this rectangle under this transformation. So you have to work hard a bit, but for the timing I'm just assuming such a choice of C is possible. One choice is this rectangle, and such that C star contains 0 and not 1. So why is that important? I'll tell you now. So then I is what? 1 by 2 pi I C star at 1 by omega power n 1 minus omega d omega. So again we'll use the Cauchy residue theorem. So this integral is nothing but 1 by 2 pi I is here due to this fellow here, and by the Cauchy residue theorem it is 2 pi I times the residue of the function at 0. Why at 0? Because only 0 is, look at this, only 0 is there inside C star and not 1. So what we have done, firstly converted this residue into an integral, simplified this integral in terms of omega, and again converted this integral in terms of residue. So what is the advantage of that? Calculating the residue of this function is very easy. What is the residue of this function at 0? Can you tell me? 1. You can just do the series expansion of this and you will get it. Like why it is 1, you can just write this. This is nothing but 1 by omega to the power n, and 1 by 1 minus omega is what? 1 plus omega square and so on. And if you just multiply whatever n you give me, the coefficients are always going to be 1 of each term, and hence the coefficient of 1 by omega will always be going to be 1. So the residue is 1. So thus we are done. Okay, so therefore the residue of the function, so So this thing was very important. You have to choose such a curve such that C star contains 0 and not 1. Why was this important? Because calculating this residue in that case will be easier, and then only we can apply the Cauchy residue theorem. Otherwise it will be residue at 0 plus residue at 1, so that will again increase our work. So any problem, any confusion? Okay, we're done with these things. Let me have some more time and discuss one more question maybe.
Sir,
Yes, hello.
sir, can we do it by manual induction?
Okay, maybe yes, why not? Yeah, take n equals to 1, determine the residue, assume for k, and then prove it for, but like how will you express for the power k plus 1? How will you compute that? We do not have any such result that you can multiply two residues or something. Do you have any result? For 1 it is easy, you can do, for 1 it is easy that you can show it as 1 and assume it for k, but how will you start from this line? Residue of 1 by 1 minus e to the power minus z equal to the power n plus 1 at 0. How will you proceed next? K plus 1 for instance.
No, we have to
Sorry?
consider the zero पे single pole, zero पर pole है of order k k. मतलब
Okay.
अगर अपन n इक्वल्स टू k के लिए देख रहे हैं तो जीरो पे ऑर्डर मतलब पॉल है ऑर्डर k के लिए, तो जो पॉल के लिए डेफिनेशन जो दी हुई है मतलब डेरिवेट करना है k माइनस वन टाइम और k माइनस वन फैक्टोरियल से डिवाइड कर देना है, तो उस डेफिनेशन को लगा सकते हैं और उसके इक्वल टू में हम 1 रख सकते हैं।
Okay, okay,
एंड
okay.
आफ्टर अपन हम k प्लस वन के लिए करेंगे तो वहाँ पे मतलब ऑलमोस्ट हो चुका है, बस मतलब कि मैं ये पूछना चाह रहा हूँ कि जो सॉरी डेरिवेटिव और लिमिट को एक्सचेंज कर सकते हैं क्या?
ओके, मतलब तुम इसको बोल रहे हो ना, तुम ये वाला फॉर्मूला लगाने का बात कर रहे हो, दिस फॉर्मूला, राइट?
क्या सर?
सो तब तो तुम डायरेक्टली कर सकते हो, बट यहाँ पे है k plus 1, so if I use the formula, if I use that formula, तो तुम बोल रहे हो this will be 1 by k factorial times d power k dz k, and यहाँ रहेगा z to the power k plus 1 times, ओके इसका डेरिवेटिव ये बोल रहे हो, राइट? हाँ, सो इसको एक बार डिफरेंशिएट करना, यस यू आर समवट गोइंग इन द राइट डायरेक्शन, इसको एक बार डिफरेंशिएट करना एंड k माइनस 1 पावर्स जो आएगा उसको प्रीवियस से 1 डालने का कोशिश करना।
ये सब मतलब ऑलमोस्ट हो चुका है सर, एक स्टेप में 0/0 का मतलब टर्म बन रहा है, बट अगर अपन लिमिट और डेरिवेटिव को एक्सचेंज कर देंगे देन इट विल रिजॉल्व।
Okay, so your question is that can we
इंटरचेंज द लिमिट और डेरिवेटिव?
Yes, you can do it because I guess so. Okay, एक मिनट सोच के मैं बताता हूँ, वैसे मैं थोड़ा देर में कैंपस आऊँगा, सो मेरे पास लेके आना, मैं देख दूंगा एक बार, ठीक है?
ओके सर।
हो गया कैंपस में, हाँ। Okay, so we have some time, or let me see what can I
हेलो
do.
सर।
हेलो हेलो
सर मैरोमैर्फिक फंक्शन की डेफिनेशन एक बार बता दीजिए।
समझे नहीं, क्या बोले तुम?
मैरोमैर्फिक फंक्शन की डेफिनेशन एक बार क्लियर कर दीजिए।
अच्छा, just a minute. So maybe I'll not be able to discuss more questions today. Okay, so मैंने एक दो क्वेश्चन और सॉल्व करके रखा है, अगर तुम लोग को चाहिए तो मैं तुम लोग को भेज दूंगा या वहाँ पोस्ट कर दूंगा, मे बी आई विल एक्सप्लेन इन द नेक्स्ट क्लास. सो आई विल डिस्कस दिस मच फॉर टुडे, एंड जिसको जो भी डाउट है लाइक पीयूएस हैज आस्क्ड हिज डाउट, तो वो मैं क्लियर कर दे रहा हूँ. ओके, एंड अदर्स में लीव इफ यू डोंट हैव एनी डाउट. जस्ट अ मिनट पीयूष. हेलो हेलो मनोज, तुम्हारा आवाज नहीं आ रहा है.
हेलो सर,
हाँ मनोज,
शीट 4 का क्वेश्चन नंबर 6 देखना.
क्वेश्चन नंबर 6 तब डिस्कस करा था, रुको तो. अच्छा पीयूष, मैं बता रहा हूँ तुम्हें मैथमेटिकल फंक्शन, जस्ट वेट करो, मैं एक बार 6 डिस्कस कर देता हूँ फटाफट.
ओके सर.
Number 6. So limit z tends to 0 modulus of fz divided by e to the power 1 by z. This is 1, and this is same as saying that modulus of fz behaves similar to e to the power 1 by modulus z as z goes to 0. Okay, these two statements are equivalent. Now question में क्या बोला है, that 0 पे क्या है, isolated singularity है, right, and z equals to 0 is an isolated singularity of fz. isolated बोला है, क्या बोला है, हाँ isolated ही बोला है, right. Okay, so what was the question? Let me read the question, just a minute. Is there a holomorphic function f on this such that this limit is 1? So suppose, what is my assumption is, suppose there is some so let's write this way. Suppose you can start the bracket. Okay. Suppose there is some holomorphic function, analytic, what was the given? Okay, holomorphic given hai. Yeah, holomorphic function will show that this will lead to a contradiction. Is some, suppose there is some holomorphic function such that this happens. मान के चलो ऐसा कुछ है, and as z equals to 0 is an isolated singularity with, अब ये चीज नोटिस करो, from this condition fz tends to infinity as z goes to 0. क्यों? Because at when z is tending to 0, e to the power 1 by z tends to infinity, right, and these two functions are behaving in the similar manner, so fz will tend to infinity as z goes to 0. So that will imply then f has a pole at z equals to 0. इसका जस्टिफिकेशन मैं दे रहा हूँ. So क्या बोलना चाह रहा हूँ मैं कि क्वेश्चन में दिया हुआ है z equals to 0 is an isolated singularity of fz, and just notice करो why I am saying this यहाँ से, because e to the power 1 by z goes to infinity as z tends to 0, तो same will happen with fz also. And this जब भी ऐसा condition achieve होता है, when the function is going to infinity at some point, then that point is the pole of the function. Okay, so then f has a pole at z equals to 0 of order k, suppose. Okay, but then fz के पास fz अगर ये की ऑर्डर का पोल है 0 देन फंक्शन जो है अप्रोक्सीमेटली किसकी तरह बिहेव करेगा, a by z to the power k, right? Because pole of order k है, and then if you evaluate this limit fz by e to the power 1 by z, this is limit z tends to 0, a by mod z to the power k e to the power 1 by mod z, this limit will come 0, which is a contradiction because this limit was given to be 1.
सर हेलो
हेलो हेलो
सर, आप ओ एक बार बैक जाना।
हाँ बोलो।
यहाँ पे सर मॉड एफ जेड इज इक्विवेलेंट टू ए अपन मॉड जेड टू द पावर के आपने कैसे अज्यूम किया? ए में भी फंक्शन ऑफ सम जेड एज वेल ना?
समझ नहीं आया।
सॉरी,
क्या बोले? ये मैंने कैसे assume किया?
या आई एम सेइंग सर ए इज कांस्टेंट और ए में भी पॉसिबल दैट ए इज फंक्शन ऑफ सम जेड।
No, a is constant. Is constant.
एक्सप्लेन सर प्लीज, हाउ कैन यू अज्यूम?
Because xz का अगर हम लॉरेंट सीरीज एक्सपेंशन लिखें and z equals to 0 is the pole of the function, so expansion कैसा रहेगा somewhat? Suppose some constant a0 plus a1 by z plus a to the power, or suppose I'm taking this a by z to the power k in this sense somewhat. Okay.
ओके सर।
Because the pole of order k है. Okay, so that's all for today. And Piyush, you just wait. Rest may leave. Thank you. So,
हेलो सर।
hello.
हेलो सर।
Hello, बोलो बोलो।
सर ये लास्ट क्वेश्चन में जाना जो आपने अभी कराया।
हाँ बोलो।
हाँ सर, यही सर ये मतलब सर लिमिट 0 कैसे आई लास्ट में? नीचे 0 into ये इन्फिनिटी हो रहा था ना।
अच्छा ये तुम बोल रहे हो ये लिमिट कैसे 0 आया?
यस सर यस।
अगर तुम e to the power 1 by z का एक्सप्रेशन लिखो तो पावर सीरीज एक्सपेंशन में तब वो 0 जाएगा। जस्ट चेक करो एक बार। आई गेस जाना चाहिए 0 एलिमेंट।
यस सर समझ गया।
समझे? तो e to the power 1 by z को अगर तुम सीरीज एक्सपेंशन लिखो, आई होप दैट विल गो टू 0। मैंने टू बी ऑनेस्ट मैंने उतना इवैल्यूएट करके नहीं देखा है इसको, बट यू कैन जस्ट चेक दैट e to the power 1 by z को तुम करके देखो, आई गेस जाना चाहिए वो। ओके
यस सर।
हाँ, सो आई जस्ट स्टॉप द रिकॉर्डिंग देन एंड पीयूष को मैं बता दूँ।